The question 10, it is show that if the normal process is wide sense stationary, then it is strict sense stationary. We know that the characteristics of a stationary process or a strict stationary process is that the statistical properties of the process do not change over time, or the number of discrete times. And if the environment and the determined conditions of the problem being studied do not change over time, then we can consider it a stationary process. And about the wide sense stationary, there is states at any time fluctuate above the and below the same constant, and the value of the autocorrelation function is only related to the time difference. And if the n in the definition of strictly stationary process is limited to 1 to the resulting definition of second-order stationary process is still stronger than that of WSS process. So if we want to prove that the normal process is strict sense stationary, we need to show that the fx x1 to xn and t1 to tn is equals to fx x1 to xn and t1 plus xm to tn plus xm for any n and any times 1 t2 and to tn and any xm epsilon. And also we know that xt is normal, so there is fx x1 x2 to xn and t1 t2 to tn is equals to the answer we showed in the paper on the paper, and where there is a constant equals to the epsilon x minus n times x minus 10 times t. And finally, by the derivation, we can see that the constant is equals to constant times t1 minus t2 and t1 minus t2 minus t3 and so on to tn minus 1 minus tn. And it's equals to the original constant. So that is, we know that ti minus tj for any I not equals to j, where I and j is equals to 1 to and so on to n, the answer is equals to constant. So by the according to the definition, we can see that if the normal process is wide sense stationary, then it is strict sense stationary.